stable until it isn't. We build tools to keep life from wobbling. Schedules, rules, defaults, routines. Over time, those stabilizers can become a kind of quiet authority, especially when conditions change faster than the tool can learn. Automation optimized for stability tends to perform beautifully in the normal case, while becoming brittle at the edges, because it is rewarded for reducing variation, not for honoring the full range of human reality. The impact is not simply occasional error. It is a predictable pattern of misfit. Stable case winners get speed, consistency, and lower costs. Edge case people in situations absorb delays, denials, and confusion, often without a clear path to contest the outcome. When the environment shifts, new constraints, new behaviors, new risks, the automation keeps enforcing yesterday's assumptions, and stability becomes a form of inertia. Stability-focused automation begins with a simplifying move. Define a small set of inputs that can be measured reliably. Then map them to decisions that can be executed consistently. That approach has a clear incentive. It makes performance legible. Metrics like uptime, throughput, average error rate, and cost per decision reward the system for doing the same thing repeatedly with minimal variance. The feedback loop is straightforward. The more a system hits the metric, the more it is trusted. The more it is trusted, the more decisions it receives. The more decisions it receives, the more the metric reflects the stable majority, and the less the edges are seen. Who benefits? Operators benefit from predictability and reduced workload. Organizations benefit from lower unit costs, fewer discretionary judgments, and the appearance of fairness through uniform treatment. People who resemble the training data, those living inside the expected patterns, benefit from fast approvals and fewer frictions. Who bears the cost? People at the margins of the model bear it. Those with atypical histories, mixed signals, irregular access, unusual needs, or changing circumstances. The cost shows up as time, lost opportunity, degraded access, and the exhausting labor of proving one's legitimacy to a system that cannot recognize it. At least one explicit constraint usually drives the design: limited attention. Human review is expensive, slow, and inconsistent. Automation is introduced as a constraint management strategy. Reduce the number of cases that require careful contextual judgment. That constraint leads to an explicit trade-off: efficiency and consistency versus adaptability and nuance. The system cannot maximize both. If it is tuned to be stable, it will resist change. If it is tuned to be adaptive, it will accept variability and the costs that come with it. Edge case failure is rarely random. It is often catastrophic because the automation can scale a mistake. When conditions drift, new patterns, new forms of behavior, new risks, the system's stable rules become miscalibrated. If there is no built-in mechanism for disagreement, appeals, or periodic regrounding, the automation creates a second-order failure. It not only makes the wrong call, it also blocks the social process that would correct the call. The system learns from what it can see. If edge cases are filtered out or silently dropped, the system's future improvements are trained on a narrowed world. In that way, stability becomes a kind of self-protection. The automation reduces variance, then uses reduced variance to justify itself. Intent is not impact. Under changing conditions, the deepest break is not technical, it is relational. Dignity erodes when a person's situation must be compressed into a small set of acceptable fields, and anything outside the template is treated as noise. Agency erodes when the only options are to comply with the form or disappear from the process. Responsibility erodes when no one can explain why the system decided, only that it did. Automation is often described as neutral procedure, but no system is neutral. Every system encodes values. A stability-optimized system encodes a preference for the typical and the previously seen. That preference can be reasonable in a narrow context, yet it becomes harmful when it is mistaken for truth about people. Attention matters here. When a community's attention is trained on averages and dashboards, it stops noticing the outliers until the outliers become a crisis. When attention is trained on speed, slowness is reframed as personal failure rather than as a signal that the system's map no longer fits the terrain. And when attention is trained on stability, change is treated as an intrusion instead of a reality the system must account for. The question is not whether automation brings benefits. It often does. But whether the benefits are purchased by exporting harm to those least able to absorb it, and by hiding that export behind smooth operation. Notice where working well is defined as reducing variance, and consider what kinds of lives become invisible under that definition. Name the edges in any process, the cases that do not fit, the people who need translation, the moments when context matters more than speed. Notice the signals a system listens for, and the signals it ignores. Consider what forms of consent are meaningful, when the path to appeal is unclear or costly. Name the trade-off that is being made: efficiency for adaptability, consistency for discretion, without pretending both were achieved. Notice, too, how responsibility is distributed: who can override, who must comply, who pays in time, and who never sees the cost. When stability meets change, what breaks first is often the person who cannot be averaged. A system that scales must also account, and responsibility remains, even when no single hand is on the lever.